it's really hard to drive things to 100%. And so when we kind of came to all of those conclusions, we said, okay, it's pretty clear that the ideal thing to do is a big bang migration. That doesn't mean it's going to be easy. It just means that we think it might actually be a little easier and it'll be a better experience for all of the engineers at Stripe, which is the priority of the whole thing.
Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, today we're joined by Tyler Krupicka. Tyler's on the developer experience team at Stripe, and we're excited to have him on to join us to talk about his role and his recent experience helping migrate Stripe's codebase from Flow to TypeScript. But before we get into that, Tyler, would you like to tell our audience a little more about yourself?
Sure, thank you for having me. So I'm on the JavaScript infrastructure team at Stripe. Broadly, we're kind of focused on improving developer productivity for any front-end applications across the company. And like Justin mentioned, my focus most recently has been migrating us from Flow to TypeScript, which has been quite a long process.
So what exactly does that team do, other than like the project we're going to talk about mainly? What are some other initiatives that this team has led?
Yeah, that's a great question. So I'm inside of the developer productivity organization at Stripe. And so for a little bit of background, there's probably over 10 teams in developer productivity there. And like some of them could be some of our, what we consider like core build code testing teams. So that's like our build infrastructure, GitHub source control, our developer environments. But there's also like language and developer specific teams. So specifically my team is focused on JavaScript, but we also have teams that support like the Ruby API, Java services, data science, things like that. And so as far as like my team goes, we're really focused on like build times or other things that could really slow down front-end development. So the type system's a big thing, but we've also done projects around dramatically speeding up the build times or improving the reliability of tests or things like that.
So is all the code in like one code base? Is that kind of why you have to have have these teams?
Yeah, so Stripe is very close to a monorepo, not quite a monorepo. Because some of our code has different like compliance requirements, there are some like separate repos. And so we have some of our front end code in one repo, but the majority of it all is within one big mono repo, just in different directories. So when you have that going on and you have some like huge applications all in that mono repo, there's a lot of extra tooling you need in place to make that all work nicely and orchestrate everything. We use Bazel pretty heavily for kind of breaking up this big mono build. I think actually recently one of the engineers who works on our Bazel implementation put up a blog post on the Stripe engineering blog about how that is all set up. But that's definitely like one of the big focuses a lot of engineers at developer productivity help with.
What do you use as a repository provider? Is it like a source control? Is it like Perforce?
We use GitHub. We have an enterprise GitHub
Okay.
instance and a team that manages that as well,
Okay.
which, yeah, it seems like they always have a lot of work to do as well, just making sure the GitHub experience works well when you have a huge code base with lots of pull requests open against it.
Yeah, monorepos in Git, like really big monorepos in Git can be...
Yeah, just even the
challenging.
Git command line can get pretty slow sometimes unless you have people actually focusing on optimizing it. Yeah, it seems like Git is a lot better at like scaling to many different repos than it is for scaling to like a monorepo, but it's definitely doable and a lot of people have their work cut out for them making that happen.
Do you know how they optimize it at all? Because like if I was given that problem of optimize the Git repo, I'd be like, well, I don't know, like remove the big files.
I think the main one that we have to work with is just like having a ton of branches open will cause problems. And like you can imagine if you have, hundreds, thousands of engineers working, they're creating a lot of branches. Not all of them get closed cleanly. There's also like automated branches and things like that. So keeping those really under check is one thing that I know off the top of my head that helps a lot. And there are some like tricks that you can do on the command line as well. So like For example, we try to follow a naming convention for branches. So I always like prepend with my username. And there's also some like Git CLI flags that you can set so that you only fetch branches for your that like start with your username unless you like explicitly fetch them. And so that also like helps when you're pulling master. You're not sitting there just waiting for minutes and minutes till it's coming down. You can prune a lot of that away that you're not working on.
Pretty wild.
Yeah, that's a useful tip. I'll have to do that too, because we do the same thing where like it's our username slash like a linear ticket.
Uh-huh.
So let's move on to the TypeScript migration now. Let's start off with why. Why go from this huge Flow code base to a TypeScript code base? That sounds like an immense amount of work and could lead to like an immense amount of problems. So why even do it in the first place?
Yeah, that's a great question. So like a little bit of background on kind of the scale of Flow that we had. Stripe started using Flow, I think, pretty early on in like its usage, which is around 2016. And I think that kind of came along with also leaning a lot more heavily into using React, which I think is pretty commonly how people ended up using Flow. And at the time, that was like a really reasonable thing to do. And, Stripe is itself really big on type safety. Stripe also maintains Sorbet, which is the type checker for Ruby. And so like all of our Ruby has that as well. And so that's been in use for quite a while. We've grown all of the front end applications a lot. And so between all of that, there's probably about 5 million lines of Flow typed code in the company. 3.5 million of that is just the Stripe dashboard, but like Stripe Elements or the Stripe JS SDK or all of like our hosted payments flows and things like that, those could all be written in Flow as well. And I think at the beginning, TypeScript and Flow had a lot of parity. There was a lot of things in the React ecosystem that had Flow support early on, but over time that's definitely diverged where, like, say you want third-party type definitions for anything, like everything has TypeScript support, barely anything has Flow support. I think the TypeScript documentation has also really come a long way too. Just there are some utility types that I'm not sure are even documented still on the Flow website. And so like, TypeScript has obviously invested a lot into making it really good. It's come a long way. So that's helpful. I think also like the way things are going, almost all of the new tools that come out try to support TypeScript syntax out of the box. And so when you're thinking about, starting to use next generation build tools and things like that, you want to make sure your code's going to be compatible. And then I think one of the bigger things that also kind of nudged us to prioritize it was around May of 2021, the Flow team put out a post that basically said, like, we're going to be focusing a little less on community engagement. And, they have a ton of developers at Facebook who are using Flow. And so they're really putting the roadmap to like making things great for all of those engineers. But what that means is like feature requests from the community or from other companies are going to get deprioritized. And so TypeScript has been really good about having this like really public community driven like roadmap and like test cycle and everything. So that's been really helpful. And then the other probably last thing is like the editor integrations as well. So, TypeScript and VS Code are just like VS Code's written in TypeScript. They're perfectly paired. There's a lot of new features that come out for it. And Flow has definitely put effort into improving their editor integration over time, but they're still a ways behind. And so, being able to auto import, sort imports, get all of the like JS doc formatting and everything really nice in VS Code, all of those features are really highly requested and really nice.
I think it's a really interesting case study in open source to compare the lifecycle of like Flow and TypeScript. So Facebook has this pretty common thing where they build open source projects for their internal use, and they make it very explicit, like, this is for us and we have high standards for what it means to open source something. We open source it, you can use it, you can get involved, but like we're building it for us. And React is very famous about this, right? They'll not release features that they've had internally for years until they're like stabilized or whatever. Whereas like Microsoft tends to productize even open source
for sure
projects. So it's like TypeScript from early on became this like formalized like product that they were working on, and they sort of treated it that way. And I think over the years you can see the sort of difference that makes. one of my old colleagues from Artsy, Orta Therox, was on the TypeScript team for a while, working on documentation. I mean, that's like mainly what he did. Is like, I want the onboarding experience to be better, and just the fact that they sort of prioritize that enough to sort of hire somebody just to focus on like make this experience really good. I mean, says a lot about what what that team is doing, and then all these little things like their every release log that they put out is just so good. It's so good. There's like so much information. Yeah. So
yeah, you can see the difference in like amount of hours that have been put into the TypeScript playground versus the Flow playground. If you just go check those out, like the Flow one is perfectly functional, but the TypeScript one is like way over the top. They've got like select different versions, tons of examples, everything. There's been a huge investment there.
Yeah, big shout out to Orta, because he like invented a whole technology stack to make that possible. So it's really cool.
Yeah.
I have a question for both of you guys. Have either of you guys written Flow before? I'm curious.
No.
I actually have. When I was first starting to get into type JavaScript, I think like most people, like the theoretical architecture of Flow was more interesting. How it did type checking, it like sort of builds like this graph underneath the hood, and it seems like the more sort of quote unquote correct way to approach TypeScript or like typing. So initially I actually liked Flow better than TypeScript, and there were things that like in the early days were not necessarily well documented with TypeScript, and it was kind of hard to figure out like how to
and there was a bit of a priority on Angular too versus React.
Yeah, absolutely. I think the thing that really started changing that was community support, like definitely typed, basically. That what really started like stilling Flow's thunder. And then the type engine for TypeScript has just continued to get better and better and better and better. So it's like, despite the underlying way that they type check, like TypeScript has become like a vastly superior user experience.
Yeah. And I think, Andrew, like if you haven't used Flow before, like one of the most interesting things the first time you try it out that's different from TypeScript is like it has a lot more features built around inference, I feel like. So in TypeScript, if you go and like define your first ever function, the function parameters need to be explicit. So like you have parameter A, it's a string, and you say that when you declare it. With Flow, say you like go and declare a function, you don't have to give it that type parameter. And then when you call the function, say you pass in a number, then it goes and plugs in what if this was a number and runs the function and goes, oh, now you called like the string specific function on it, and it throws an error back there, which is both really neat and also I think a little bit harder to maintain over time. They've definitely moved a bit more away from that more recently in Flow, like trying to get you to put more explicit type annotations everywhere. But that whole architecture is really cool when you're first trying it out, but it definitely has a lot of limitations in itself.
So it's like generics without having to like explicitly make something generic?
Yeah. And like if you pass in a string the first time you use it and that works fine, it won't give you a type error, but then the next time you try to pass in, undefined or something, then it'll come back and go, oh no, this isn't going to work. But it's actually kind of like executing your function each time, which I think gets a bit expensive in the type system.
Yeah, I can imagine that. I feel like that functionality probably also makes it so that Flow can do the children type checking.
Yep.
Because like the thing that I've always wanted in TypeScript, that's the only thing I would want from Flow, is that you can type your React children and restrict that your menu only has menu items as a child, where you can kind of do that in TypeScript, but what you get in the end is not what you want, even though it's kind of what you want.
Yeah, that's definitely one of the main areas I've seen Flow excel at. There's a couple things too, like in the TypeScript types, there's always a couple small rough edges around maybe like functional component return types or something. You can't just like return react.react node and like strings and nulls and numbers inside your functional component. And since like React and Flow are both like working together a bit more, that stuff works a little more cleanly. But everything else with like the JavaScript standards and like syntax and types for the DOM and everything is really, really exhaustive in TypeScript. So definitely a lot of perks there too.
Yeah, the last thing I'll say on it is always bet on Anders.
Yeah,
You got 40 years of language building experience. That might come with some good knowledge, some domain knowledge there.
definitely.
Yeah, for sure. Getting back to going through this migration, I've had to do some big TypeScript migrations as well, and they're always interesting. Just large code base migrations,
Yeah.
period, are interesting and have their own unique challenges. What was your approach to this, and how did you verify that okay, we did this
Yeah,
correctly?
that's a great question. So I think the initial planning for the migration really took place like almost a year ago at this point, and it was really like just a discussion about if we were going to take this on. It seems like it's not going to ever get completed. How do we like think through this in such a way that we can actually complete it? And so I think initially a partial migration was like a little bit more appealing. Like, can we take a big app like the dashboard, break it down into subcomponents, and then do a bunch of smaller migrations and just get like a cadence going of doing that? And that does sound like a good idea up front. And I think if, say, you were coming from an untyped code base over to TypeScript, I think that would work really well. Like, you're not really losing anything by having some files be TypeScript. You'll just have types where you didn't before, and like everything can only be better. But as soon as you start looking at a partial migration between type systems, everything starts to look way more complicated. So especially like our code bases can be really interdependent. You don't always have like really clean like boundaries between all of the different modules inside the code base. Some utility types might get shared around everywhere, things like that. And so if you're going to migrate part of the code base, how do you approach keeping type safety at the boundary? Like, you basically have to either commit to just losing type safety for a little bit and hope you can get it back, or you have to do a bunch of extra work in order to like auto-generate types at the boundary to say like this flow code can generate TypeScript, this TypeScript code can generate flow. And that's like almost double the work, because at that point you have to build tooling to go the opposite way of the conversion as well. And I think one other thing that kind of stuck out thinking about that too is beyond just like the technical aspect, if you're an engineer working in a partially migrated code base, like say you're trying to do a feature that's in TypeScript in one part and in Flow in the other part, like how is your VS Code gonna handle that? Like, you're gonna have to have both editor integrations going. It's gonna use so much memory. You might have to be regenerating types at the boundary as you're working. So there's just a lot of questions about how do you make that like a good experience and what are the trade-offs. And what we kind of came to was there's going to be a real loss in developer velocity if we're in like an inconsistent partial state. There's a decent chance we could stay in an incomplete state long term. Like, you guys have worked in some larger code bases. How often does a migration actually hit 100%? It's probably like 5% of the time or something. It's really hard to drive things to 100%. And so when we kind of came to all of those conclusions, we said, okay, it's pretty clear that the ideal thing to do is a big bang migration. That doesn't mean it's going to be easy. It just means that we think it might actually be a little easier and it'll be a better experience for all of the engineers at Stripe, which is the priority of the whole thing. Like, people really want TypeScript, but do they want it enough to be in like a really inconsistent code base for 6 months or something like that? And so once we knew like Big Bang was more of a focus, we could start planning around that and going like, okay, what can we do to like automate this? What has already been done? Can we look in open source and find blog posts about other companies who have done migrations and kind of see how they scale up to the complexity of our code base? One other thing we did consider at the time to try to make things easier was maybe upgrading Flow even more or spending more time on it. Because as time has gone on, Flow has actually added a bunch of features that bring it a little bit closer to TypeScript behavior. One of the biggest differences that you'll notice is Flow objects are inexact by default. So say you have a React component and you define props for it. Basically, like when that component is used, all of those props are typed, but any extra props that you add are just typed as any because the object's inexact and you can expand it with any extra field on it. And so people can say that they're exact and they can add in like a little marker for Flow to say treat this as exact, but in practice, most people wouldn't remember to do that or would have other reasons not to do it. And that is like an example of a feature where it's pretty clear over time, like especially if you're writing a lot of React components, you'd like your props to be strictly type checked. Like if somebody misspells the prop, you'd like it to like underline that instead of saying, oh, this is a new prop, I'll just give it an any. And so like Flow has added a bunch of flags that like ratchet up the strictness. Like there's an exact by default mode. There's another mode called types first, which like any of the places where it's doing that fancy inference, it'll like force you to annotate. And that's also a big performance increase as well because it just has less to do. And so we kind of looked at doing a bunch of those upgrades and we're like, well, could we get our Flow syntax a lot closer to TypeScript, and would that make it easier? And what we kind of found was there was some like marginal benefits. Like it was nice getting some performance bumps when we updated things, but in general, the amount of work required to go like over to exact types and everything was going to take months and months. And those were months that we could instead focus on just going to TypeScript and turning it on at the same time. So there's a lot of decisions that went on around that, but it was pretty clear that we'd have to lean into automation and that we could kind of leave our flow types as they were and just work with it.
So what was the ultimate solution that you guys went with? Did you find an open source library that could do most of the work for you, or did you make something?
So I want to say it was like August or September of last year, I started looking at the different open source implementations and just trying them out. And we knew that the first thing we needed to convert across the company was just the design system. The design system's a sub-dependency of pretty much everything. And it also was going to need to support both Flow and TypeScript while we're doing the migration because there's new features coming out. And so that made everything a little bit more tricky. But we knew like if we wanted to convert any application, they all use the design system pretty much. And so I started trying out some of the ones that were available, and the two main ones I was looking at were the Khan Academy one, which comes up pretty quickly if you just search for like Flow to TypeScript. I'm pretty sure the package name is Flow2TS. And that one worked pretty well. I think it uses JS Code Shift or something, but especially for just like basic type conversions or utility types, they had a lot of that worked out. The other one I looked at was from Airtable. They had recently open sourced that, I think, when we were looking. They have a Medium post about how they migrate their pretty large code base. I want to say it was 1 million lines using it. And I found that with their code mod, the foundation of it was really clever. So instead of using like JS Code Shift outright, they pretty much wrote their own implementation for going and finding flow files, parsing them with Babel, applying a transform, writing the files. And I was a little confused initially about why you would go through that trouble, but it became clear pretty quick that it was necessary. Like, for example, JS Code Shift, I don't think it easily supports like just renaming the file extension because it's focused on like transforming inside the file, not renaming the file. And so like that was one thing right away that popped up. We're like, oh yeah, how do you do that? It's not really focused on that. But there was a bunch of other small things we could do. Like we could pre-scan the file and figure out if it's a declaration file and like skip over it. Or we could do some other like scanning on it. Is it a JSX file? Rename it to .tsx. So there was some optimizations you could do there. And then the other cool thing that they did was in all of those cases where Flow is inferring like a parameter type or something where it's required in TypeScript, the Airtable engineers wrote a sub-process that basically runs Flow in the background. And then it feeds Flow this command called type at position, and it just gives it the position of the type you're looking for and has Flow spit back the inferred type for you. So for really simple...
That's actually really cool.
So for really simple types like this is a string or a number or something, it can just give you that back from Flow, and we can put that in and we can run it through our normal conversions. We did end up making a ton of enhancements to that implementation over time, but kind of the combination of being able to parse the files really nicely and query Flow was like a very obvious good foundation to start on. So that's where we based everything to begin with, and we started it by just testing against component after component in the design system and starting to work on it.
For our listeners who might not be aware, could you talk a little bit about JS Code Shift? Because we'd mentioned that, and
yeah, so I can talk a little bit
maybe
about just like the code mod architecture and like what goes on. So JS Code Shift is a really neat tool that basically allows you to go and parse a code file And then what it'll give you back is what's called an AST, which is just this big kind of graph representation of the file. And you have some functions that you can use to traverse it. So like say you wanted to find every function declaration specifically and make some small modifications to that, or go look at every function parameter in the file. JS CodeShift gives you like an easy way to just kind of give it a source directory and a list of transforms to go run, and it'll go do it. So what the Airtable code mod and what our code mod ends up doing is pretty similar to that, where you like give it a directory, it goes and it finds all of the .js files, and then it reads them to find out if they're Flow files. And for those of you that haven't used Flow, in Flow you have to put a comment at the top of every file that says @flow. You can also put an @noflow at the top as well to say not to check it, but that's what actually lets the type system know that that file should be type checked. And so we kind of go through, look for that, and then we use Babel and another package called Recast, where we have Babel go and parse the whole code block and give us back all these nodes. Then we have a bunch of little transforms that are saying like, go to every variable declaration. Check if that variable declaration has a type annotation. If it does, put it through this like function that will go try to find the equivalent in TypeScript and convert it out. And every time we make a change to that big kind of AST graph of the file, Recast is tracking that. And so at the end of making all of our changes, we tell Recast, go right back to the file with all of our changes. And it does that. So that's kind of the basic structure of how it works. And I think inside of it, we have like 8 or 9 different main types of transforms. So there might be like a file that's looking at all the classes and doing transforms for them and their methods, or looking at all the imports and doing transforms for them. And that's kind of how the whole
Yeah, that's really cool. When I first started getting into Codemods, which is just like, it is just automated code to modify, it's a program to modify your code. When I first started getting into them, I thought it was really, I don't know, it was kind of scary. It's like, it seems really complicated from the outside, but there's this tool out there called AST Explorer, which is probably one of the best, if not the best tools for just like learning how code mods work. Cause it's a like playground with like these panels, and it's like your source code and then your code mod and then what it generates in the AST, and just gives you this really good experience of like almost any type of code, whether you're writing TypeScript or JavaScript or Flow or whatever. So if you're ever interested in learning how to write code mods or just want to play with it, astexplorer.net is your friend.
Yeah, definitely. We use that a lot on the Babel parser setting.
Yeah.
For our listeners who might hear AST and seem scared, like it is a scary sounding topic at first, but like once you understand it, like it unlocks so much. Like recently I used AST Explorer to look at the AST for my React code and then use it to be able to know there was a relationship between two components. So we have an icon button in our design system, and for an icon button, it has no text. And you want to enforce that it either has an ARIA label or a tooltip. With the AST, I can just go look, find all the icon buttons, and then check, does it have this certain prop? Nope. Go up the tree. Is it in a tooltip? Nope. Okay, error. So very useful, and it opens up a lot of like the ability to customize your tools a lot.
Yeah, and it's how things like ESLint plugins and a lot of other, like even like, what's it called? There's the CSS build system, like some of those plugins. PostCSS, like those also have like an AST for CSS as well. And so yeah, you can make a lot of really cool programs. And one other thing that's really nice about writing code mods is it's one of the few places where you can almost always do test-driven development, which is not always the case, especially when you're working with user interface code or like JavaScript code. But it is nice where you can go like, okay, I'll write this little program. Here's what I expect it to get transformed to, run it through my transformer. Does it come out? And you can write out all of your test cases really nicely. And that was one thing that we focused on a lot in our code mod. I think there wasn't a lot of like test coverage available for Flow to TypeScript conversions just across all the projects. And so with ours, like every change we made has like a test case for it. And we definitely would have broken things over time if we hadn't put that whole suite in place.
Yeah, it's so fun to go back to test-driven development when you don't do it predominantly. Like
Hmm.
another package that both me and Tyler worked on while we worked at Intuit was post CSS themed. And
Hmm.
literally every time I wanted to add something to that package, I just go to the test file, write up what I wanted to work, and then hack away at the code until the test passed. It's such a good feeling.
Yeah. Hmm.
I mean, that feels like the purest form of programming. It's like you just have inputs and
Yeah.
outputs, and that's like it. It's
Yeah, I
like
feel like I was always promised that in school that that would be how I could do all my development. And that's the right way to do things. And then in practice, a bunch of things can't actually be tested that easily,
Yeah,
especially when you're
then
writing
the
like
real
CLI
world.
applications or things like that.
Yeah. So going back to the code mod, was it perfect? Like, were there certain situations where it had to bail out and go, this is too complicated of code. I'm just going to start putting any's or like to do comments in there. One code structure that I feel like might have been very hard to do because I've dealt with them a lot is generics, like
Hmm.
converting one type system's generics to another type system's generics seems like a very non-trivial problem, even more non-trivial than converting 3.5 million lines of code.
Yeah. Yeah, so the code mod is unsurprisingly not perfect. And we've definitely made a lot of improvements over time, but I think it would be very hard to get to perfect for the reasons you just said. Like there are places where, especially like utility types too. So, TypeScript has a lot of utility types like omit, pick, whatever, and you can chain together to make some pretty complicated requirements. Flow has the same sort of things available, but the Flow utility types can also do like even more inference with them as well, which makes them even harder to map over. So there's like one called object map, or I'm pretty sure how it works is like you pass in an object and that object has keys and then the values are functions. And it will actually give you a type back that has the key and then the type of what the function will return when you pass in the type from the value. And so it's like inferring the type of the function and returning that in utility types. And there's just like no easy way to convert some of that. And so some of those things kind of remain the same, or like we convert them the best that we can, but they're not going to go over cleanly. The things we can do though are identify like really common patterns in the code, especially around like we're in a React code base, so anything around defining components, props for components, or things for typing the API or coming out of GraphQL or things like that. So focusing on it there. Kind of how we approached iterating on the code mod was we started with that design system. So we started with simpler components and just kind of worked our way up to more complicated components, probably making one or two patches per component almost at the beginning to support some different syntax. And then from there, we moved on to an app that was probably a couple thousand lines of code. So not super complicated, but definitely had some new things in there. It's got React Router, it's got Redux, things like that. And then from there, we moved on to converting Stripe's CI infrastructure over to TypeScript, just like all the user interface for it. And doing that was about 50,000 lines of code. And that definitely exercised a lot more different types, and we were able to make fixes there. At that point, like there was a couple thousand type errors or something after converting that code base. And that was kind of when we started hitting the limit of like, okay, this isn't like manually fixable anymore. If we're scaling up to bigger and bigger code bases, like we're not going to be able to spend a lot of time looking at every single one of these types. But we were able to focus in on the highest priority things that we were seeing repeatedly. And a couple things we did too that helped out along the way for refining it. The code mod has a command line argument that will go and grab all of the TypeScript errors, sort them by error code, then like sort them by file, and then put them into a spreadsheet for you. And so you can very easily kind of glance through that and go, wow, we have a huge block of like this specific thing is undefined, or a huge block of parsing errors around classes, what's going on here. And so using that, you can start to narrow in on like, these are the areas the code mod isn't converting very cleanly, and kind of triage the errors. To give you an idea for the big code base, when we got to the Stripe dashboard, the first time we ran it had almost 100,000 TypeScript errors. And so we got a monster spreadsheet out of that to start picking through and making patches for. But over time, we were able to really drive that down. I think at the end, we ended up with like 38,000-ish. And now we're at about 30,000, which is still a lot, but significantly reduced. And a lot of the errors, you can't even just easily make a hand modification to the type or something. So for example, there's a huge block of errors that are like, this could be possibly undefined. And maybe that's something Flow wasn't checking previously and TypeScript's a little stricter about. And the real code change is figuring out whether or not it actually is undefined and fixing the types or adding a guard or something like that. But we want to preserve those errors. But one thing we also found that was helpful for figuring out whether or not we were maintaining type safety was just going ahead and generating type coverage for the whole code base and seeing how we were doing. So Flow has a built-in type coverage tool, and so we could run that and see whatever percent we were at. I want to say it was like 92% type coverage before, and that's just asserting that there's not like any types like cascading throughout the code base, and everything has something a bit stricter than that. With TypeScript, there's a NPM package, I think it's just called TypeScript coverage, that will give you the same kind of report out of TypeScript. And so we could monitor that over time and say, are we damaging our type coverage at all, or is it roughly equivalent? It wasn't a priority to have it be exactly the same. We were fine losing a little bit of coverage just to get migrated over. But what we found after doing a bunch of iterations on it was the type coverage was reporting slightly higher, which was pretty surprising because we had more suppressions, more errors, and those reduced coverage a bit. But we had so many new like type definitions available to us for all of these third-party dependencies that were not very strictly typed because we might have handwritten them before. And so having all of that available actually made the type coverage increase slightly over time, which is great.
So if you have 30,000 errors left, does that mean you're not actually type checking during build, like you're just omitting files?
No. So we are type checking during build. And basically, once we started seeing the number of errors that were there, we were going, oh, we need to have a system for automatically like triaging and suppressing these if we can. And so we added another command to our code mod that is just focused on fixing types after you have converted. And as far as I know, that's like a new thing. I didn't really see any other code mods focused on that. But one of the features we can do is just go through and add a suppression comment above every single error and do a TS expect error, so that as people fix type errors or improve them over time, it'll give them an error to remove the comment as well. And we also have a command to remove all of the unused TS expect errors, which is actually something I'm kind of surprised they don't have in TypeScript just as a feature natively. But definitely after conversion, where we have all of these suppressions, we want to be able to go back, have people fix a few hundred of them, and then just have them automatically deleted. So we put together some tooling to help us with all of that. So we added in suppressions, and we can actually get to a TypeScript check that passes and runs on builds. One other kind of interesting thing, TypeScript also has some suggestions. They've been getting better about like, hey, you're using a value as a type. Did you mean to insert type of before this? And so for some of those kind of errors, it's like correct 98% of the time or something like that. So we could also, take those errors and then attempt to just apply the fix automatically after with TypeScript's added context about all of the code, which is really neat.
Yeah, that's awesome. The suppression approach that you're talking about is actually really common for moving from non-strict TypeScript to strict TypeScript. So when I was at Artsy, we did a big migration that started on the mobile app Eigen, and it was like the same sort of thing. It's like turn on the flag and then automatically add TS expect errors everywhere that the errors occurred with a message, and then like having a script to make sure that like no more of those get introduced and like try to strangle them out over time. It's a good approach. It's
it's nice that they have the TS expect error comments, because if you threw in ignores, that'd be a huge kind of extra risk for type safety. When types get updated, those don't get cleared out. So you feel a little bit safer knowing that like when the error is getting fixed, those comments will also get removed and it'll get better over time.
Yeah, it's my opinion that you should never use TS ignore. Like it should never be used.
Since the code base is so big, like, do you guys build everything, every pull request? That seems like it might take a long time.
That's a great question. So when we first started to do the initial runs and we had all those errors, we were pretty quickly running into some performance problems with TypeScript. It's a huge amount of files, and just the sheer number of errors also increases, I think, the memory usage of TypeScript. So I think it got better as we reduced that. But, having to go and increase your memory a bunch on your laptop so that node doesn't run out. Because I think it's only 4 gigabytes by default. It was pretty scary to start out with. But we did a few things that really helped bring that back into the realm of reason where people can run it regularly and it works nicely in their editor. The main thing that we did was looking into project references, which for people who haven't used them is how TypeScript tries to scale the larger code bases. You can basically point out different areas of the code base that are isolated, and you can say this is a project on its own, type check it on its own, cache the types for it, and then don't recompute it unless files inside of it change. So it's just like a good way to kind of cache types across the code base and keep the memory usage lower. Unfortunately, you can only use project references when you're not like cross-importing in directories. And so in a really large web application, it's really common to just cross-import everywhere. You write a React component in one directory, use it in another one, and so on and so on. And so it's really hard to set those strict boundaries. And we pretty quickly realized that it wasn't going to be possible to set strict boundaries for pretty much all of our main core source code in the dashboard. But what we could do is cache any of the slowest loading types that we could find, and we could cache things like our test files, which have like a one-way dependency on all of our source files. And so the first thing we looked at was using the TypeScript profiler to figure out what files are taking the longest to type check. And unsurprisingly, the thing that popped up first was we have a huge file of generated types for GraphQL in our API, which is probably pretty common in a lot of applications. And so if you've got everything in one file over there, those are all getting loaded into memory, even if they're not changed, and that can really slow things down. So we made that a project reference. It's not very many files, but like all of our generated API types and everything can stay as a project reference. Like I said, we split out our tests into a separate project reference. Those ones get recomputed a little bit more frequently since people are editing their test files, but because at least they have the one-way relationship where tests import source, but hopefully your source isn't importing tests, you can block that off and then cache that as well. And so with the incremental mode turned on in TypeScript, we're able to take each of those areas that was slow, generate a TS build info file for them, and make TypeScript a lot more performant and quicker to start up once you have it generated.
That's pretty cool. Yeah, I've looked into project references before, and they're a little bit complicated. You have to like check in some of your DTS files, like I don't know. They're just like certain artifacts that have to be like present for it to like.
And for us, we don't end up checking in any of the cached DTS files. We just keep those locally on people's laptops for the time being. Gotcha. So that does make it so that it's a little bit less like churn where somebody might get conflicts or something with that file. One like big opportunity for us going forward will be using those cache files more heavily in our CI system, because locally you can run TypeScript. It might take a few minutes to go and actually generate the TS build info files the first time that it's run. But once you've done that and those cache files exist, then TypeScript is much quicker, taking seconds or something to only check the files that you changed. And so we can hopefully leverage a lot of that same stuff in the CI system. It's not crazy out of control at the moment, but like over time we can make that experience a lot better, which is nice.
So how did the actual rollout of all of this go? Were there any like significant road bumps along the way? Did people react with pitchforks and fire, or did they welcome the change with all the new TypeScript?
Luckily, it's been a lot more of people openly welcoming the change. Kind of a month before we did the migration, we had like gone through and reduced the number of type errors, and we felt pretty confident that we were getting close to having a passing build. So we started communicating out to teams and saying, your code base is going over to TypeScript in about a month, we think. We'll keep you updated. And I think people were responding and just going, what? It's actually going to happen? And like, you're moving all of it? What do we need to do? And it's like, no, we're moving all of it. And So it was really cool to like have that enthusiasm kind of building as we're getting closer to it. People were stepping in to help out, test the application, like as we were getting ready, check out our TypeScript branch, see how things are going. Actually getting up to like the point of the migration, we had to do a bunch of work to figure out how to make it less risky when we're changing all the extensions. We kind of found over time that you would think like we're changing tons of lines of code throughout this huge code base, that the riskiest thing would be modifying all this code. But because we're switching type systems, if the code mod is working properly, we're not actually changing the runtime behavior of any of this code. We're just modifying the type annotations. But what we are doing is we're changing the extension of every single file. And so like your Webpack entry points, all your other tools need to be able to look for that extension and resolve it. And so it was helpful to have like engineers jumping on board and testing their part of the product and letting us know if anything went weird with changing the extension. And after we had actually converted, people came back and we were a little bit nervous initially. Like we knew the first couple days were going to be a little bit bumpy, where you might have to restart VS Code, or a lot of people might have turned off TypeScript on VS Code because they had Flow enabled. And so there was like a bit of education to go, oh, if you turned it off, you need to go re-enable it. Here's where that feature is hidden, and get everyone back in a working state. If people had branches or pull requests that were put up in Flow, those now had to be run through the code mod and rebased and things like that. And so, there's a little bit of concern, like, will people be okay? We're asking them to do a bit of work. And come Monday and Tuesday after the merge went through, the feedback was pretty much overwhelmingly positive. People were really supportive. They were really enthusiastic to get TypeScript, and they were pretty patient with us as well as we, got everything to stabilize and got everything working. There was a lot of people who on Monday came in and said, oh, this is the best day. I'm so happy I'm on TypeScript. I noticed my folder that I work in has a bunch of type suppressions in it, so I'm going to spend today fixing all of those, and I'm really excited about it. And it was great to see like that really can-do attitude come out and have a lot of people help fix everything up immediately after, because, there's only 9 people on our team, and there was only like 4 of us who were completely dedicated to TypeScript right after it. And so it's not enough people to fix up everything in a 3.5 million line code base.
That's really awesome, though. That's the gratifying thing of working on tools, right? It's like you build stuff for people that you sit beside. It's the internal customer that's so just satisfying.
Yeah, and it's great. Like if something goes wrong, we can they know how to reach out to us. We can chat with people, and they're really supportive, even if they know it's broken. Still happy we're fixing it. And it's great to hear people come back too and say like, I'm going through and triaging some of these errors, and TypeScript's already helped me find a couple bugs in our code. I think the favorite error, which you guys have probably seen, is TypeScript has this helpful thing that's saying you're checking if this function, but you're not calling the function. This will always evaluate to true. And it's really easy to miss that just while developing. And I think there's been like a couple of people who have found those here and there. Like, wow, it's great that it could identify it for us.
Yeah, that's a great one. On the topic of all of this work, next obvious question from our end is like, are you planning on open sourcing any of the tools around this?
Yeah, so the good news is pretty much everything that we worked on as far as the tools for it will be open sourced probably before this podcast even airs, which would be great so people can check it out. We're in the process of putting together a blog post that kind of outlines the general story of the project. There's a lot of details too about how we actually ran the migration over the one weekend in March. And so all of that will be available, and the code mod will be up there. Since we've done manage, or the Stripe dashboard, that's what the code base is called, we've also done some other migrations as well. We've been working on converting some other internal sites. We've also converted like the Stripe payment elements and Stripe JS SDK, things like that, over to TypeScript. And so as we've been doing that, we've also been moving all of those fixes into the open source version, so they'll all be available day one. Yeah, and so we've also written up a bunch of documentation about it. It should be, if you want to try it out on a Flow code base, it should only take 10 or so minutes to get set up and to clone it, build it, and start running it.
So what's next? What's the next huge thing for your team to conquer now that you've bested the TypeScript beast?
That's a great question. I'd like to say we've completely bested it. We're not quite there, but we're getting there. I think probably the next big opportunity, which some of my teammates have already made some great progress on, is around sharing code inside of our big monorepo. So we have all this JavaScript code, and as you guys are probably more than aware, like if you're in a big code base, it's very easy to either have different directories where you can't easily share code across them, so you end up copy pasting things, or you might have parts of the code base where it's way too easy to share things and you end up with the interdependent code that you can't like break apart. And so we've been working on a lot of tooling around making that whole process easier, how to package things, ideally also so that you don't have to do an npm publish and a version bump every time you're changing some core dependency. I think, moving to TypeScript also has driven home to us as well that it's like really helpful to start putting more investment in keeping all of our tools the same version and getting a regular rhythm around like keeping that all up to date. With Flow, all of our code bases were on relatively recent versions of Flow, but they weren't necessarily the same. And for the type system, it is really helpful to have every project in your code base on the same version. Like if TypeScript does a new stricter check, you have to start turning off skip libcheck because like some other packages in your dependency chain might not pass the new strict version, things like that. And so we're trying to keep everyone in sync there. And I think there's a lot of opportunity to do that for other tools as well. Like if you're an engineer working on an application inside of this big repo, you're trying to put together the best product code that you can, and you'd rather not spend a day or two keeping your version of Babel up to date with everyone else, or keeping your version of ESLint or TypeScript up to date with everyone else. So the more that we can help manage that and make it less of a burden for teams, I think that'll be really helpful.
Then last question we got. Do you have any like new developer tools that you've seen on Twitter that you're just like excited to come out or excited to use? There's a lot of cool new ones popping up.
There's a lot of really neat, anything that's been popping up with of an emphasis on like performance and TypeScript support, like the ES builds and SWCs, or any other tools that kind of, are really focused on making front-end development really fast and functional with TypeScript. It's always really exciting to see that, just because I feel like we're in a pretty good spot with like the actual syntax of JavaScript, but like simplifying all of those tools and making them really fast is a very immediate benefit. I think anything too around like editor integrations or any other like lint rules or checks that can catch things like in the code editor, I'm always really excited about. Yeah, it's always really nice to just get those hints right as you're typing versus having to wait for a CI build or things like that. But TypeScript definitely brings a lot of the errors and hints into your editor a lot quicker. So I think that's one of the big reasons people like it.
Yeah, for sure. I love all the native tooling that comes out. I think that is like the future of JavaScript tooling is all native. Because it's like, that's where you really eke out your performance. There was a long time where we optimized for like, hey, we just all want to write in the same language. It's like we all just want to write our code in TypeScript. It's like our tools, our CLI, our web apps, our backend, we all want it to be the same thing. But there's a right tool for a right place. And if you're processing, hundreds of thousands of files or whatever, it's like, that having a native tool to do that actually makes a huge difference. So super stoked about like Rome and Bun and ESBuild and all these. These are all great projects.
Yeah, and I don't think that I've spent enough time actually going and trying out all of those, but it's definitely exciting to see like every new tool come out. The first thing they're obviously focused on is how can I make this like really nice and performant for people. And yeah, I think that's a huge improvement because like you said, I think performance, like we focused a lot more on language features for quite a while and a little bit less on like the performance of all of the front end tooling. And simplicity tool, like, too. I think for a long time, front-end development required understanding like a huge variety of different tools, and that's slimmed down a little bit, but it's also nice to see people taking new, fresh attempts to try to simplify some of that.
With that, let's move on to tooltips. So the first thing I'm going to share today is a React library called Virtuoso. If you've ever had a very, very, very large list with lots of things in it in React, you might notice that your page performance tanks. That's because React is rendering every single row, and even if it's not on screen, it's actually in memory still being rendered. So a common technique to solve that is called virtualization, where you only render rows in that thing that are visible on screen, and then maybe like a few off screen in either direction. That's called overscan, to try to like make it not seem like things are just popping up as you scroll. The two big libraries to do this in like the past decade now, I guess, has been first React Virtualized and React Window. Both of those libraries were written by Brian K. Vaughan, a former member of the React team, and they kind of come with similar limitations. The biggest limitation in my mind is you kind of have to like say, here's a box, here's my window. Things in here are virtualized. You have to give a height and width to that window, which is kind of a drag, and just it sucks in practice because like a lot of the time you have a responsive browser. You don't know what the size is going to be, so you have to start adding mutation or intersection observers or whatever to handle that. This library has some pretty cool things that make it very easy. The one I want to call out in particular is, I don't know if I'll be able to find an example here, but they have this prop called use window scrolling. So basically, it allows you to window and virtualize your content, but not have an extra box where there's a separate scroll bar where you have to scroll. So where I've been using this is in Descript's project browser. We have this area where there's like nice static content that's like visually pleasing. Then below that's the project browser. If I'm using React Window, I have to scroll down, and then there's this box where I can then scroll and things are virtualized. With React Virtuoso, I can use the scroll of another element and it all works. It does it by adding padding for all of the cells that aren't on the window instead of using absolute positioning like React Window does. So now when you scroll on the page, it's like it feels like one big long page, even though a section of that page is being virtualized. So if you've ever wanted to add virtualization to your app and were limited by the windowing of React Window, this is a great option. And it has a nice, easy API, and I've had a good time with it.
Is this a new package, or has it been around for a while?
I think it's fairly new, like probably within the past year or two. And yeah, it one of the other things that it does really well that React Window doesn't really do at all is you can render tables with it. And with tables, you have to have a very strict structure of there's a table and it has a T head and a T body, and you can't have any divs or anything in between that. So to get that to work with React Window is kind of hard because like it's adding things in there to make the windowing possible, and you can kind of override them, but a lot of the time it's kind of clunky. This has a built-in table component, so you don't have to worry about that at all, and it's easy to use.
Nice.
And results in valid markup, which is in the end of the day one of the most important things.
Mm-hmm.
Yeah, super important. So I saw this got reposted on Twitter. So I think who posted this? Devin, the Adobe Spectrum guy. What is his
haven't learned
name?
how to say it yet. Govet, I think.
Yes. Yeah. Anyway, so Devin posted this, and it's an article titled "Building Data-Centric Apps with a Reactive Relational Database." And it's a pretty dense article, but one of the things, like the core tenet of this thing is really bringing your database closer to your application. And there's a project that actually embodies this that I really admire. So there's this project called Actual. It's like a budgeting app.
One of the members of the Stripe design system team.
Yeah, exactly. Yeah. James
Longster?
Longster. Yeah, something like that. Me and names, not getting along today. But anyway, so the principle is, a lot of times we build applications and we have an API and we have like all these complex layers between like the product experience that we're building, the data that we're connecting to. And it's a complex series of things that we do to sort of build these things. And this article is sort of like talking about strategies to bring that closer, where maybe you run your database right at your UI level. So Actual does this by running SQLite on IndexedDB, like right in the browser, and it just synchronizes the SQLite versions by like basically doing tail locking. Anyway, this article sort of talks about that setup and then architecture, and just like is thinking through like what would this look like and what are the benefits and what are the system properties of it. I find myself a lot, especially recently, thinking about like how overly complex just building simple digital products has become, and just having so little patience for it. It's like I used to be such a huge proponent of GraphQL, and it has a lot of great properties, but like building APIs are really, really complicated. How you name things, how you set up type generation, how do you do automatic generation, persistent queries for GraphQL. I mean, even a REST API, all these stuff gets really expensive. So I'm starting to value more and more simplicity. And it's like, miss the days where you could just like do a SQL query and get the data and render it on the screen. Anyway, great article. Definitely recommend you check it out. It's got a ton of detail. Just a fun thought experiment.
Luckily, a lot of things are moving that direction. Like I would categorize Remix as that. We did an episode with the TRPC guy, and like I started using that on a side project, and it's just a breeze to use. You don't even think about those things.
Yeah, and in that episode we talked about like Blitz.js and how it basically has like an invisible API where you're just importing server modules and it like generates an RPC interface for you. It's like that kind of stuff is really interesting. I mean, these aren't zero cost abstractions. Like they're abstractions and you pay for them in some way. But like, I don't know. I'm all about reducing cognitive overhead, and yeah, I'd like to see more of it.
Yeah. So if you're interested, you can read this very, very dense article about it.
It's quite extensive. It's really, really good. Do you recommend?
So this one is very relevant. It's a package called ESLint Bankruptcy, which great name, better functionality. It basically does what we were describing with the TypeScript error suppressions, which is like, say you want to add a new ESLint rule, or say you just migrated 3 million lines of flow to TypeScript and you may have disabled a couple rules along the way to make it work, and you're turning back on the rules and there's some new ESLint errors. You might as like, if it's just a few, you can go ahead and fix them, but as soon as you get into the hundreds, you don't want to be in there manually suppressing them or fixing them. So this tool basically lets you just run a CLI on your code base and say, find every instance of this ESLint failure and just go ahead and suppress it, and all of the new ones in the future will become an error and we'll handle it then. But for right now, we're fine with the ones that we have. We just want more strict syntax. So it's a pretty good example for me of like a pretty simple tool that, you know, does what it says on the tin and is very straightforward, but is very functional as well.
I feel like this would pair really well with something like Betterer, the tool that like we've talked. I think this was a tooltip in the past, but Betterer is a tool written by a former Spotify engineer, Craig Spence, and it basically helps you incrementally cut down on certain things, like I don't know, TS ignore rules or ESLint ignores. So it like tracks all of them throughout your code base, and you basically have a test that like will only pass as it gets smaller or whatever, and you can like set goals and whatever else to like hit migration targets. It's like I think more of these tools in the ecosystem would be great, because it's like this is how big migrations get done. It's like you need tools to help people do it without blocking their day-to-day. Anyway, I'm a huge fan of this project, and it goes like really well with things like that.
Yeah, definitely isn't the first time we've talked about it. Okay, so my next one, this is one I have not used at all, but I could see how it would be very useful, is a Tailwind CSS plugin for Radix. So you might ask, like, wait, why would I need that? Why you need that is because how Radix works a lot of the time is it will set states on things as data attributes. So, for example, say you have a toggle group where there's 3 buttons and only one of them can be on. When one of them is on, it will add data state equals on. And all of these utilities help you capture those things. So if you look at the little code snippet right here, it adds things like radix state open border 2, which when that data attribute is present on the element, it will add a border. So this can really help you not write any of that CSS and just plug directly into Tailwind, which is probably what you would want to do anyway. So if you've ever needed something like that to marry the Tailwind CSS and radix together, this would be a good option to go with.
Awesome.
I'm not super familiar with radix. What is that?
Oh, radix is definitely my favorite library I've come across in the past year.
Oh, wow.
So you know what Reach UI is, but for our
Yeah.
audience who doesn't, Reach and Radix are both have the same goal, and that goal is create React components that are fully accessible but completely unstyled. So you can use these components to craft your own design system, just like I've done at Descript, and you can use their primitives to build up your actual components. So instead of building a drop-down menu and having to read the Y aria spec and get all the keyboard interactions right, you can just use their component, add some classes to it, and then boom, you have a design system. So Radix is a great option in that. They go a lot farther than Reach. Reach has like a combo box and like a few other things. Radix implements like 75% of the Y aria components. So
Wow.
it really covers most of what you need.
That's really neat.
And yeah, and all the packages that they use are very, very helpful to build your own design system. My favorite bit of DX that they have in there is there's this function called compose event handlers, where you can go, my onClick is compose event handlers. Then the first argument is your props. So you do props.onClick, and then you do the default behavior when you want an onClick. And what the cool thing about that is if the first prop callback handler calls e.prevent-default, it won't call the second one. So if you want to override something in that happens, you just go, prevent default in the onClick. So you can use that, like Radix has a lot of stuff where it focus manages, but sometimes maybe you don't want the focus to go back from the menu to the trigger. And in that case, all you do is on unmount or whatever, you say prevent default, and it prevents the default behavior. So very cool library to both use and to look into to build your own stuff.
That's great.
Yeah, it's awesome. They do a lot of little clever things. It's like that they have another prop that's like as child or whatever, like as a way to override the type of component.
Yeah,
I don't know. Really
that's their
interesting
slot component. And I actually just used that today with React Virtuoso. React Virtuoso doesn't, like, they render your table row like in a separate place than when you're like actually like returning from the function for your table row. So instead, like, I originally had a package patch in there where I like modified their code, but then I realized, wait, I could just make each table row a slot, and then the slot is going to spread all of the props and the important stuff to the thing below it, which is the code that I control. And then I didn't have to have my patch anymore, so I just deleted it. It was great.
Yeah, love it when that happens. So yeah, my last tool tip for the day is this library called Meros. Anyway, it's a really simple library. It does like one thing really, really well. It's for reading multi-part responses from an API. So if you are downloading a lot of information potentially, sometimes you have a lot, like you'll have a multi-part HTTP request that you do. It can be really, really annoying to handle these things simply, but this API gives a like subscription like API that makes it really, really nice and really, really simple way to just get data from your multi-part API. I've had to deal with this in the past, and it's always annoying. And this API, it's just so simple. It's like, I love it.
What is a multi-part API response? Like, when would I get one of those?
Well, maybe, so concrete example, you could be, well, I don't know. There's like many different ways. Like if you're downloading like structured data and you've got like a lot of structured data, you might get it like served to you in chunks, and it can be used for a lot of different things. But it's usually always just an API response as large that you're breaking down into parts.
Yeah, I think I've used this for like file uploads, but
Yeah.
I might be wrong.
Yeah, so this is, both of my tooltips were related to the TypeScript migration in some way. This is a package called tsmorph. We use tsmorph inside of our code mod for the fixing command. But basically, like if you want to write a code mod for some sort of JavaScript syntax, you're probably using Babel. Babel has like a pretty well-defined tree for everything and a lot of tools built around it. But if you want to do a code mod that also needs access to TypeScript's type information, tsmorph lets you do that. So it will parse a TypeScript file and you can make modifications to it, but at the same time you have access to what TypeScript knows about the file. So you can more quickly go modify types, or you could write tools that go try to auto-fix TypeScript errors or things like that. And so it's a really neat extra level on top of like normal code mods, but we were able to use that to write our scripts for automatically suppressing errors, for removing suppressions. But there was also some interesting things like TypeScript has an auto import feature, and tsmorph exposes like pretty much all of TypeScript's API for you. So we could look at a file, check, does this file have any this variable is not defined anywhere or this type is not defined anywhere errors? And then we could go ask TypeScript like, hey, is there an auto import available for that thing that's missing? And just get that back and add it in. So it's a really neat way to script on top of TypeScript and all of its type information.
That's as one of the most delightful parts of TypeScript to me is all those like little code transforms that like seem to just make their way in by interns on the TypeScript team. My favorite one that I think I use the most now is you can in VS Code right click source action and then remove all the unused code, which oh my god, it makes it like if you want to like get a component out of one file into another, just copy the whole thing, delete everything you don't need, right click to remove all the unused code, and you're in a great starting state.
Mm-hmm.
And with that, I think we're done with the episode. Thanks, Tyler, for coming on. This was a very interesting and detailed dive into what a large-scale TypeScript migration would be like. So thanks for coming on.
Thank you so much for having me.
Yeah, thanks, Tyler. It was great.
Well, that's it for this week's episode of DevTools-fm. Be sure to follow us on YouTube and wherever you consume your podcasts. Thanks for listening.